Welcome to this video on trigonometric ratios of standard angles. So first, a quick warning, please pause and read. In the previous video, we mentioned one of the uses of trigonometry could be to find height of a tree. So the way you do that is you walk away from the tree, probably let's say a few meters, let's say 50 meters or something, and then try to find out what is the elevation of the top of the tree using an instrument like sextant. And if this elevation happens to be, let's say, 30 degrees, then you can actually use your trigonometric ratios. So in this case, let's say your tan 30 would be equal to your height divided by 50 meters. And we can actually find out the values of tan 30 and other trigonometric ratios like sine 30, cos 30, and so on, right? So in this video, we are going to focus on two angles. One is a 30-degree angle, and to find the various trigonometric ratios of 30-degree angle. And the second one would be 60-degree angle. So let's get started. So here is an equilateral triangle of side 2 units each, and all the angles of equilateral triangle being 60 degrees. Let's draw a perpendicular from one of the edges to the base, and as we know, this perpendicular line splits the side into two parts and two equal parts, and also it splits the angle into two equal parts. So that's 2 becomes 1 and 1. Here 60 degrees becomes 30 and 30 degrees. Now we can find the height of this the height of the perpendicular line, and that would be square root of 2 squared minus 1 squared, that's square root of 3. Now we can draw the half triangle that you see here and draw it like this. You may be wondering if it's true only for side with length 2. In fact, what you will find is the ratio remains the same for a similar triangle of equal angles. So instead of 2, if the side become 2x and the base is 1x, you will find that the height is root 3x. So since we're dealing with ratios, it doesn't matter whether you take a general triangle or a small triangle. So here's a small triangle, and our objective is to find the different values of sine, cos, and tan for 60 degrees and 30 degrees. So please pause the video and try to reflect and find out what are the various values for all the trigonometric ratios. So pause the video here. To do this, we can first mark our angles and say, hey, for 60 degrees, your perpendicular would be here, the base would be this one, and hypotenuse would be this. So sine 60 would be, we can use a mnemonic, some people have. So sine is perpendicular by hypotenuse, so P by H, some people have. Perpendicular by hypotenuse is root 3 by 2. Curly brown hair, so cos is curly, brown is base by hypotenuse, curly brown hair, that's 1 by 2. Till painted black, so tan is perpendicular by base, so that's perpendicular by base, that is root 3 by 1. So that's the different values for the 60 degrees. So we can straight away draw our table. Now before we draw the table, the reason why we said it doesn't matter what triangle you pick up, whether it's a general triangle or a specific triangle. So let's assume that this is 2x and this is root 3x and this is x. The ratios won't be any different. So as you can see here, perpendicular by hypotenuse would be root 3x by 2x, and that's be still root 3 by 2. So the ratio does not matter what triangle we pick up, right? So let's go to now the 30-degree angle. So for the 30-degree angle, this would be the perpendicular, and this would be the base, and this would be the hypotenuse. The hypotenuse is same. So sine 30 would be, some people have perpendicular by hypotenuse, that is 1 by 2. You can see that sine 60 was root 3 by 2, sine 30 is 1 by 2. Cos 60 is base by hypotenuse, and that is root 3 by 2. And tan 30 would be perpendicular by, till painted black, so perpendicular by base. So that's 1 by root 3. So what you can see is sine 60 is same as cos 30, cos 60 is same as sine 30, and tan 60 is reciprocal of tan 30. So it's nice to see these patterns as you do these. So some people like to remember this in a tabular form. So you can write this as sine, cos, and tan, and you can write here 30 degrees and 60 degrees, and you can write all the values of what you found. So this would be root 3 by 2, tan 30 is 1 by root 3, and for 60 degrees, sine 60 is root 3 by 2, cos 60 is 1 by 2, and tan 60 is root 3 by 1. Now it's easy to think of the complementary functions, which is the secant theta. So secant theta is 1 by cos theta. So in general you can say, hey, secant 30 would be 1 by cos 30, and that would be equal to 1 by root 3 by 2, which is 2 by root 3. Similarly, let's say cot 60 would be 1 by tan 60, that is 1 by root 3 by 1, that is 1 by root 3. So it's easy to find for secant, cot, and cosecant, etc. You just need to find the inverse. But I would highly recommend you not to remember this in a pure table format, but to always remember it with a triangle, and that'll always be handy, and you can never go wrong. So in a 60 degree, 30 degree, this would be a root 3, and from this you can construct this table whenever you want. So before we wind up this video, let's do a quick checkpoint. So here are the checkpoint questions to find the values of sine, cos, tan, cosecant, secant, and cot. It'd be nice if you can start from the basic triangle and deduce all these values. So I hope you enjoyed this video. See you in the next one. Bye.